Welcome viewers. In this lecture we will be discussing about Jacobian matrix. Jacobian matrix is a matrix of all first order partial derivative of a multivariant function. Here we assume that this y is a function of some multivariables where we have x1, x2, x3 and so on. All are dependent on x. So if we have n such functions, y1 is given by this, y2 is also this, and yn is this, then we can find out the effect of a small change in these independent variable on the dependent variable. So for that we have to differentiate this function and partially, so that we can find out the total change in y1 due to the differential change, very small change in x1, x2 and so on. So we can have these equations, and finally if we write these set of simultaneous equation, then in matrix form, so we get this matrix form for these equations. So here this matrix, which is the linear first order partial, as we have already seen in the beginning, that output variable, that is xi, we can write these like this. So here if we have n number of joint variable, then the effect on the end effector will be either in x, y, z, these are the locations, the position, and then gamma x, gamma y, gamma z, these are the orientation part, that is what is the angle about x axis, y axis and z axis. So we have, in any case for manipulator, we will have 6 output parameter, and when we have n number of input parameter, these are the joint variables in case of manipulator. So for every differential change in joint variable, it may affect the output parameter. These are x, y, z, that is the position of manipulator and the orientation of manipulator. So if we partially differentiate, we get these 6 equations, and these 6 equations can be written in matrix form like this. So where this J11 is nothing but this is a partial differential or differentiation of function f1, which is given by this, and every function will be in terms of h0, 0, 1 to hn 0. So this we can write in that form. So if we have 3 degree of freedom manipulator, in that case dx will be given by this. So here we are differentiating this with. Thank you very much for this brief introduction to Jacobian. We will be taking a few examples of the Jacobian so that we can understand how these are to be used for evaluating the different parameters, the differential changes in the end effector with respect to the differential change in joint variable. Thank you very much.